And now last point is, if some unique thing happens, people tell us about this advertisement 16, 18, 17, 19, 20, this one, not about this, the sort of the graph we will have, this time we will have a graph like this. Will a graph like this. Am I correct? This is case number 4. In the case number 3, can we get some sort of future prediction? Like if chi-square value says there is a association between the two, like I have written here, the point says 25, 5, 45 and 15, it will say yes, there is a association between the two. It means, what is meant by the association? When advertisement is high, sales was found to be high in majority of cases, but we were even having the cases when it was not high, but in majority of cases it was high. When advertisement was low, majority of the cases sales was low, but we had the cases of low also, high advertisement also. So generally we found there is a positive relationship, that there is the two are associated. Please look for one thing, in case of cross tabulation, we don't use the word relation, we use the word association. In first one, regression, there was correlation, there is a relation, but here we don't talk about correlation. I will just in a minute I will explain why we don't count that word. But before that, if the case number 4 is there, it will be like this. In this case, actually we will draw a regression line, though it should not be, we will draw a regression line, and if I will write regression like this, y is equal to a plus bx, you understand dependent variable is in terms of high and low, dependent variable is high and low. So the future prediction, what you require, future prediction will again be in high or low. Okay. In regression we were doing like this, y is equal to a plus bx, if x is equal to 100, y is equal to, you put the value. But here I want, if x is equal to 100, y is what, high or low? My dependent variable now, take example of, instead of high low, if I will put it as Amul or Vadilal, I want you to write a equation using this method and tell me if somebody with this age comes, whether he will purchase Amul or Vadilal. I am interested in H or L, Amul or Vadilal. I am not interested in a mathematical number like this. So in this regression, which is called as logistics regression, we will draw equation and there will be a cut point. If somebody will get marks more than this, this will be called high, this will be called low. It is logistics regression. Well, again, if you understand it, fine. If you don't, then just look at your table number 2. The cases are available with you. I just tried to explain you why it happens. Last cases, do you understand the points will be like this? Actual line should be made like this, but it is not a straight line. So if we make a straight line, it will be like this. Okay. Again, not passing through all the points, we are not concerned. Our point is we want prediction in high or low terms, in high or low. So what we will say, we will have a regression line with a cut point. If our overall, when we put x as 100, something value will come. If this value is above this, I will consider it high, less than I will consider low. So this is called as LDA or logistics regression. This is just concept, I will discuss it in detail. But one thing I want you to just look for, just compare case number 1 and 3. Just compare the two. Case number 1 was, case number 2 and 3. Case number 2 was like this, and case number 3 was like this. It's correct? If I take for the low advertisement 10 more cases, where these cases, where their sales will be most likely be, will it be near to these points or will it be anywhere? Okay. Let me give another example. What do you think is the average height of a grown up girl means 21 plus in North India? Average height. 5'2", 5'3", roughly, very roughly. Okay. If I take girls in this room, it will be something like 5 2 5 3, something like that. If I take 100 more girls, what will be the average? Roughly same. There will be some higher side, some lower side. If we take entire university, same. If I take entire North India, all the schools, colleges, almost same. My point is, if we take 100 new cases, 50 cases of low, their points will be somewhat like to these points. Some will be higher side. Anything can come here, but we will say, okay, you are outlier. We will remove them. Likely to become here. So can you see their overall mean will not affect? It has a cushion effect. It will go up and down, but very near to. And likewise, this will also go up and down. It means as you increase the sample size, your results are most likely to be same. Come to this point. If you take 100 more points, will they go 25 each in all? Any guarantee? No. So I have taken like this. If I take 100 more, can it become like this? No? Okay, this will increase here also, but certainly you can't give any doubt. Have you heard of somebody saying parametric tests are better than non-parametric test? This is the reason. As the sample size increases, look for, if you go for this one, regression, what will happen? The points are here. If you take 100 other things, where these points will be? Next points? It will go here, 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 or all the same? The same. So the results will continue. Regression is a very robust technique. If you look for both are the metric, no outlier, some common sense sort of things, its results will be replicable. T-test is wonderful, awesome. Whatever sample size you will take, because automatically it will balance itself. It got a inbuilt cushion effect here also. The results will be replicable. Chi-square test, you can't guarantee that the next 100 people will fall 25 each. It may go in any side. It may go 25, but may not go. Parametric test always gives better results than non-parametric test. Always. So for the future prediction, but you know, when we say better, it requires a number of things. It requires a sort of checking mechanism. Was your data normally distributed? Was there independence of error? And then it will ask for whether these much variations of this and variation of this are the same or not. Sometimes the t-test etc. will just act as a googly. There are the two batsmen A and B. A made 400 0 0 0, Chris Gayle, and the second is Virat Kohli. Now, if you take X bar 100 100, so now what is your point of view? Are A and B same or different? They are very much different, and if you are a captain, you have a certain choice for either A or B. Okay, let's ask t-test, are they same or different? T-test says x1 bar minus x2 bar divided by standard error. X1 bar is 100 minus 100 divided by anything, it comes 0. And the method we are told is calculated value less than table value. Anybody remembers what we do? Null hypothesis accepted. That means calculated is 2, table value is always 2, calculated 0, 0 less than 2, null hypothesis accepted. What was? There is no significant difference. T-test says the two are same. In fact, they are same. They are both 100. What went wrong? The formula of T is correct. I can guarantee you that.
Using the average, that's the problem.
Yes, T-test is made for average. So look for one assumption for the t-test. These are the small nuances which we should know. We never compared their variability. Can you tell me what it will be at sigma? How much away every atom is from the mean? They are on the mean. Here average will be very high, sigma will be very high. So that's why before applying any parametric test, t-test F, does it make sense if we compare their sigma? Does it make a sense? Had it been like this, 102, 101, 99 and 98, their average still will be 100, and now we are correct. Yes, both are almost same, no difference, because now sigma will be very, very small. Here sigma is 0, it is almost 0. It means, does it make sense to check the variability before? before applying t-test? This was said by Levin. We will talk tomorrow. What Levin says? Levin said, see, you don't go directly to the T. Before coming to T, please come to me and get a certificate whether their variance are same or not. What is it called? Homogeneity of variance. Homogeneity of variance assumption is there. Now first thing you look for whether this assumption makes sense or just is a nonsense thing. Does it make sense? If you don't take this permission that yes they are almost similar, so these sort of weird results can come. We know they are different, but t-test is saying no they are same. Reason being why? Reason being we have not consulted Levin. Levin said before going to T, please check if they are same only then go for T, else some correction factor is required. There is never ever a closed door, something will happen. My point is this friends,
So if that's the case, what will we use then?
we will do for certain correction. See, the people who do MSc stats, what they do? They also go for PhD, no? What they do? They say that whatever the technique you have devised, there is this point is lacking. Let me correct it. Somebody else will correct it. Somebody else. So,
But we can't change the data. So
who said I will change the data?
how will we correct it?
There are mechanisms. I will come to that.
We'll go to a different
Yes,
direction or different
correct. There are methods. So we adjust the degree of freedom. So that means my point is never ever you will be at a position when you say this is a dead end. I can't do anything. It will never be there. You will always find a method. Always. Yes, ma'am.
Sir, apart from degree of freedom, the standard error can be checked and then the error is stated. Then it will be
N number of methods are there, ma'am. A very simple method is this person, this is consistent. This is also very consistent. Don't look at this. This is also consistent. So, the very first thing is we should check for the outlier. We should check for the outlier. No, this is outlier. So, we will look for whether you will include that or not. There are mechanisms, but my point is only 2-3 friends. Just look for. And from the morning I am emphasizing the same. Number one, I am saying it's not a rocket science. It's some common sense decision. Agree or not? Number two, it's nobody's monopoly. Each one of us can understand to the fullest extent. Yes or no? Anything which you are not able to connect to so far? Able to connect so far? We'll just revise what we have done and then we'll stop. The third point is from the morning what we have emphasized is number one, you please look from the totality point of view, just like Google Map macroscopic view. Macroscopic view is what sort of research you will conduct, it's your decision. What sort of data you will collect, it's your decision. Whether you wish to check out a impact of something or it will be a perceived impact, it's you to judge. Variables are your invention, it's you will discover these are the variables, this interplay. You can take more, you can take less, no hard feelings for that. Finally, from the objective fetch the variables, only variables. How to write the objective, are you somewhat clear about it? That whatever the way you will write, there must be two sort of objectives are there. Either you measure a variable or find out the relation, whatever language you write it, doesn't matter. The name of the two variables should come and rest of the things are not important. So we talked about the objectivized analysis, we talked about these two things, type of data and type of study, research, and finally we talked about the measurement, nominal, ordinal. If you understand it, the problem is in the books what they write so many things and they never tell us it's not about the answer of the question, it's what inference we can draw from that answer, that is measurement. What the person replied, that's not measurement, that's the answer. The place you belong to, Agra, Delhi, that's the answer. It's not measurement. What I can infer from that, if I'll say municipal corporation area, then certainly I can say Delhi is higher than Agra. It's ordinal. I will decide that. Okay. Finally, we made two tables, table number 1, table number 2, and we tried to see the statistical Dumbledore, our dear friend Scatterpot. Scatterpot told us that it's not wise to apply regression in all the ways. There are different techniques, but in all the way, the fundamental question will be replied, are the two related? And if yes, what will be the future prediction? That holds true in all the 4 cases. So let's stop here. Agenda for tomorrow. Agenda for tomorrow, we will write a process. Tomorrow we will work on laptops. So please come with SPSS installed. If you don't have SPSS, you can download from the website. Simply write free download IBM SPSS. It will ask you to fill up a form, you have some information, and then you can download. When you download, please look for post window 8. Now you got two sort of window, 32-bit and 64-bit. So you must know about it, your system configuration. When you download, look for 32-bit system, download with 32. Two options will be there. Download and install it, and tomorrow morning we will start with SPSS. I will tell you just little bit about two stories. I will tell you one story of difference, the story of pattern, and third the story of Likert scale. It will take maybe an hour or so, maybe 1.5 hours, and then we will go for SPSS options, and finally we will go for 7-8 case studies. My objective is I will enable you to look at the data. Okay, this sort of data is there, this technique will be applied, this will apply, and the way to write. So tomorrow it will be little hectic day. Well, I hope you can understand that if we just start t-test without telling today's detail, it will be very superfluous. You know, it's a simply there is a t-test, but you will never understand why. This was the thing I tried to explain today. Any questions, you are most welcome. And at what time we will meet tomorrow? Is it possible to come before 10 for you? Not possible? 9:30 is possible? Because I see it only, you know, just I think a few more hours with me, and there is so much to discuss with you. So if possible, if you can 9:30. How many people are not comfortable at 9:30? First the organizers, are you comfortable at 9:30? It's okay? Yes, 9:30 is okay? Okay, please come at 9:30, then we will start with it. Yes, sir.
All these functions that you mentioned about this Excel, able to handle
Absolutely.
everything.
Absolutely.
Do we have to create those kind of spreadsheets, or will they come in?
So we will talk tomorrow morning data entry in SPSS and Excel, because that's fundamental. SPSS requires data to be entered a particular way. We can do everything. Okay. You can just refer to some of my YouTube videos. It's on Excel and Megastat. There is a plugin. You know, there are some plugins for Excel. You can do every single thing that you can do on SPSS. Every single thing.
What is the plugin?